not sure whether you're late. Maybe difficult to find a parking spot. Is that what? Yes, rolling around. That might be the reason. Okay. All right, so that's up, so I can get started up. I can get started. All right, so let's go back to, oh, here we go. So, good afternoon, sir. How are you? Good. How was the homework question? You say that some of them are not easy. Yeah. Yeah, so we are about is taking up the homework question. All right. So moving back to the question number 16. So let's go. By the way, it's kind of blurry, isn't it? Screen. Okay, you guys can tell me the screen is clear or blurry? All right. Come on. Want to take a seat there? And then anyone else came, and then we'll ask them to move to the front. So I need to just find the screen. So can you just tell me, is it blurry? Also, you can see sharp. Which one is sharp? Is that sharp? That's blurry. Is it sharp enough? Okay, I will zoom in. All right, so you're back from vacation. Do you have a chance to watch the video? No. All right. Sorry? I did do the work. You did the work? All right. But how did you know the work? Yeah, the work in a Google Classroom. Yes. So how do you know what to do? So you look at the notes that on the OneNote. Yeah. Okay. Yeah. OneNote. Okay, cool. So, all right. So we're gonna go moving back to some of the difficult questions they're talking about. So number 16. So let's go back to, and then where did you go on a vacation? You went Florida. Where? Orlando? Okay. Not to just go for the, what is it called, Disneyland. Okay. So determine the volume of the rectangle present shown below and express your answer as a. Okay, so that's cancel. That's supposed to be Sharon. So I'm going to see who is popping up. Yes, that's Sharon. Cool. Hi, Sharon. How are you? All right. So how did you, anyone know how to find the volume of a prism? You guys have learned volume in grade 8. The volume is calculated by, hello, how are you? Your spot is taken. You want to take a spot in the, so can you move a little back? This table, just a little back. Yeah, so that you can have a seat on the front. All good? Can you fit it? I can move. I have space here. All right. All good? Yep. Can you see that? Yep. You see the thing on the back? All right. So we're going back to calculate the volume. The volume is calculated by length, time, width, time, height, isn't it? Has everyone seen the formula? All right. So that's something that you probably have learned in grade 8. Sharon, how are you, sir?
Good. How are you?
I'm doing great. So, did you do the homework?
Yeah.
All right. So we're going back to the length. So the length is 3 to the power of 4, and the width is 3 to the power of 2, and this is 3 to the power of 3, isn't it? So how do we calculate that volume? So we're going to be simply multiply the same basis. The rule of thumb says we need to add the exponent, isn't it? So what do we get? 3 to the power of 4 plus 2, 6. 6 plus 29. I'm just following that. So that's the one of the application question. Did you do the homework? Okay. Finally, you're here. All right. So I'm going to give their homework to Mark. You're going to have a seat on the back. I'm taking up. So I don't really want you guys to, well, copy down this and then put a circle if you copy down this question from me so that may know it is not something you have done. So put a circle, right? Yes. That's okay. That's fine. I'm going to take it up. So I'm going back to the difficult question class. So, Taran, are you following that example? Cool. Now let's going back to the word problem 17. I kind of didn't like how blurry it is. I'm not sure why it's blurry. So I know that I have adjusted my screen. Okay. Let's try it. You guys gonna tell me what in front. So I'm gonna adjust the projector sharpness to see if you can see it. So that in. Maybe I need to zoom my questions. That's fine. All right. And also the color. All right, I'll zoom the question. Well, you all have a handout. So let's going back to the next one, 17. A rectangular container. A rectangular container has a volume of 5 to the power of 4 centimeter cube. So the volume is 5 to the power of 4 centimeter cube. A smaller container has a volume of 5 to the power of 6. So that is 5 to the power of 6. A smaller container has a volume of 5 to the power of 4 centimeter cube. The question is asking how many times larger the smaller to compare. I mean, how many times larger the smaller than the larger, isn't it? So all we need to do is we're going to simply divide this 5 to the power of 6 by 5 to the power of 4, isn't it? Are you following that? So that is going to be 5 to the power of 6 minus 4, which is 5 to the power of 2. Well, we know how much 5 to the power of 2 is. So let's going back to on the back. Vaishali, what is 5 to the power of 2? 20. So we can say, we need to conclude the statement. So how many times larger the volume of the bigger container? Therefore, the volume of the bigger container is 25 times larger, 25 times larger than the small. You got the same answer? All right. Did you write a conclusion statement? Why not? Well, in grade 8, it's okay. In grade 9, so if you have a teacher that Malin has, Miss Vims, right? So she takes marks off. If people write curly bracket like that, she takes marks off. That's not a curly bracket, curly bracket. So if you see bracket like that, she takes marks off bracket. This is called mathematical communication. Where did you lose the marks for? Where did you take marks off?
I drew my sine graph, it was not even pointy, it was just a little bit thing at the top, just different parts.
Yeah, so basically a sine curve is a curve, something go like smooth. So he probably have a smooth curve, so she took marks off. Well, when it's come to high school, I don't like to give a perfect mark.
She does get perfect marks.
Right?
She does get perfect marks.
So I will only give a perfect mark that's just precisely correct. So if somebody get everything is right, I will first look at it. Can I able to take marks? So well, I do give a perfect. People get perfect marks. So when it's come to in grade 9, it's more structured. So you really precisely write something. Okay. So now going back to number 18. I have no clue why it's look like blurry for me. That's okay. But you guys have the question. Determine the area of the triangle shown below. Express your answer as a power. Okay. So let's going back to Akshaya Online. What is the formula to find the area of the triangle? Area of a triangle. All right, so I'm expecting that you have learned that in your grade 8 class. Base times height divided by 2. Can you guess we call that?
Yep.
Yes, all right. So what is the base? 2 to the power of 6 millimeter. What is the height? 2 to the power of 5 millimeter divided by 2. Now we have to use the exponent rule to simplify, isn't it? So here's what you have to do. In grade 9, I want to see your steps. I will write the steps. I will write the step. This is 2 to the power of 11 divided by 2 to the power of 1, which is 2 to the power of 11 minus 1, which is 2 to the power of 10. So you guys can see we are writing all the steps that are required. You can jump from here to here in grade 10 and 11. I don't care. But grade 9, I want to see, are you showing the exponent rule. Did you get that correct? Okay. You did by yourself, no help. Very good. Okay. Are you ready? So I'm taking out all the word problem. Now, we can use an exponent law to show why a to the power of 0 is equal to 1 in most cases, which I have talked about it. Determine 2 to the power of 3 by 2 to the power of 3 by calculating. I think that I showed this one. 2 to the power of 3 is 8. Divided by 8 is 1. Now, exponent rule. So how the exponent rule work? When we divide the same bases, we talk about we have to subtract the exponent, isn't it?
Yeah.
Which is 2 to the power of 0. Based on your result in part A and B, what you can conclude? Well, we can see this is 1, so they are equal. Can you think any one of the cases where the reasoning would fail? Explain. That's an interesting one. Why do you think this will fail? Yes.
Negative exponents.
Negative exponents will fail. So give me an example.
Like
2 to the power of -5 over 2 to the power of -5.
For my example, I put -2 to the power of 0.
-2 to the power of 0. What's wrong with that? -2 to the power of 0 is still 1.
I got negative.
How did you get -1? Let me do the math. -2 to the power of 3 over -2 to the power of 3. -2 to the power of 3 is -8 over -8, which is +1. The question is asking, give me an example where something to the power of 0 not equal to 1. That's what the question is asking. So, I don't know, what do you say?
C.
Yes, on D, we're on the D. Say, can you think of a cases where this reasoning could fail? How about Sharon?
I said 3 to the power of -1.
Well, no. That doesn't fail. There's only one place it's failed. Minute. It doesn't fail.
Read the question.
Yeah, so basically that is asking, give me an example where anything to the power of 0 is not equal to 1. 0 to the power of 0. 0 to the power of 0 is undefined. If you take your calculator, try to put 0 to the power of 0, it does not exist. Yes? Are you following that? But the question is why it doesn't exist. So let's go back here. 0 to the power of 5 divided by 0 to the power of 5. What you know is we cannot divide a number by 0, can we? We cannot. So the only place it doesn't work 0 to the power of 0. It is not 1. Make sense? Other than that, it works everywhere. All right. I think that I took up, first of all, in here, all the difficult word problems. Now, moving back to any other questions asked by Charlie. Any question that you don't know how to do, or you find it difficult. My online folks. Any other question you guys find? Yes.
7 and
Number 7F. Okay, this guy. All right, so let's go back to 7F. So x to the power of 2. We're going to simplify using exponent rule for the inside a bracket. When we're dividing the same bases, the rules say you can subtract the exponent, isn't it? So this is x to the power of 2 times x to the power of, this is 6. Now, when we multiply the same bases, the rules say we can add the exponent, which is x to the power of 8, isn't it? Okay, and then 7Fn. 7I. All right. So we're going to be doing the first bracket first, bed mass. So this is we are dividing, same basis. So we're going to do x to the power of 20 minus 14 times x to the power of 18 minus 15 for the next one, right? We do the bracket, we use the exponent rule, then we divide the same basis, we have to subtract the exponents. This is x to the power of 6, and this is x to the power of 3. Now what's happening? We're multiplying, isn't it? And we multiply, what we have to do? We have to add the exponent, which is x to the power of 9. Make sense? Everyone got that? All right, any other questions? All right, so can you just do me a favor, put your name on the sheet? So, Manon is gonna cross check all your work, so this is what I gave to them last class, this is the handout, so. You guys have black color beauty to market,
Yeah.
you want some other color, sir?
Do you want this?
I don't like black color to market, because that's the same as you're doing your work. Oh, I can guess. Like green color. Alright. Alright, so I need that worksheet that you guys have done, so we will check that out to see if you guys have done it correctly. Alright, so next time you can do another paper, so you can have it handout, right? Why you giving me the whole thing? I need this homework. Alright. That's okay, you know that's the same one. Alright. Alright. You mark the one that I gave last.
The great ones. We will finish.
Sorry, I will finish my. Okay, so this one just start of the mark. This is gonna be fun. All right. So what we're gonna go back to, we are talking about another rule, and then we need to work with that rule today. So we're gonna get back. This is where most common mistakes comes in. We're gonna do some questions on that before we proceed. So this is something we're gonna see right now. So I'm gonna be doing few questions, which we talked about last class. And then my online folks, you can see that on the Google Classroom, and also here, there's a Jamboard I provided. This is the power of power rule. The power of power rule is where people make big mistakes, oftentimes. So power of power. So here it is. So we talk about power of power last class. So what we talk about in power of power, here's a few things we talk about. If you have 2 to the power of 3, and then you have a 3 outside, we can multiply these exponents, isn't it? Can you recall that rule we talked about last class? Yes. Also, if you have 2 to the power of 2 times 3 to the power of 3, we need to distribute this exponent to every exponent inside the bracket. So this is 2 to the power of 2 times 3. Most common mistake is you forget there's a 1 sitting there. 3 to the power of 1 times 3. So you write 2 to the power of 6 and 3 to the power of 3, isn't it? Make sense? We also talk about if this the same thing happened with the fraction, we have to do the distribution. 2 to the power of 2 times 3 over 3 to the power of 4 times 3. So can you just recall that from last class? It is on the handout, right? It's on the, oh, you didn't get that handout. Yes, I do have a handout for that. There we go. So if you missed that handout, that's a handout I gave. Still going to use the handout for today. All right, so if that's the case, I would like to see if you guys can able to do some few questions. And then it's technically the rest is your homework question, but we want to see if you can able to do few of them today. So I want you guys to do the number 2 on a worksheet. A, F, and then number 3, B, and D. And you guys can do that on the Jamboard. I can see the work. So number 2, A and F, and number 3, B and D. All right. So are you guys working on the Jamboard I posted? Akshay and Sharon,
Yep.
first,
Yeah.
okay? Done? So what should we go here?
1,000.
1,000? So we should put 1,000 here inside the box? We'll come back. So this one x to the power of 8, y to the power of 12, correct. This one, 7, correct. All right, think about that. Think about here, if you put 1,000, then this one has 1 here, isn't it? 1 time 1,000 is 1,000, but I don't have 1,000 here. You see that? That's right, that's right, that's right, that's right, that's right. We really look at the bracket. Right. So we work on 3B. Oh, 3B is supposed to be C. Yeah, that's fine. So this is you got this is the second bit. They asked you B. But you didn't. Okay, that's fine. So you had 3B. So there's a 3B, 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 3B. Okay. So it's pretty straightforward. Think about this. So you have 2 here, isn't it? So 6 times 2 is 12. 4 times 2 is I'm supposed to be at 6 to the power of 6, right? Yeah. Let's see, Seth, how you do that. What do you like? Right. 30. So now we have a problem. For the 30, this one takes one, next one, next one, right? 1 times 30 is supposed to be 10, isn't it? See that? So you can ask yourself what times affect something over 10. Maybe what this, right? Now you see 6 times 2, we got 12, right? So if you do 4 times 2, 4 times 2. Well, I'm okay. You can use your calculator. Don't make a mistake. Right? Make sense? All right, let me see how my online views are doing here. So I asked these guys, are you guys watching Olympics? And there's a reason I asked for why you guys watching Olympics. So Sharon, you should not answer this question. All right. So are you guys watching Olympics? No one watching Olympics. So why I'm talking about, there's something going in Canadian Olympics. Who knows it? Who knows what's going Canadian Olympics? So let's ask the next question. You know what's going on? Yes, what's going on? Why? Yes. We told Canada is the greatest country that we obey the rules, but what they have done in a practice match, not even with them, a New Zealand's practice match in Paris, the Canadian head coach for the women's soccer team sent drones to spy the practice game with New Zealand. So New Zealand team complained, and then Canada now lost 6 points on their soccer Olympic Games, and then the head coach was suspended, and then they appealed this to the Olympic Committee. The Olympic Committee say, no, we're not accepting your appeal, so you're losing 6 points. 6 points. They're doing well. They won another game today, but they won't win the medal. because they already lost 6 points. So we're not great. We spy on sports. That greedy to win the game. Anyhow, all right, back to business. Let me see. That's bringing up a Canadian image back on the international level. Oh, wow. Canada spying on soccer. All right. So now I need going back to Akshaya. See what Akshaya has doing it. So that is page 1. Oh, I'm not sure why you put it 1,000. So first one is right. Second one is Akshaya. Can you tell me why did you put 1,000 outside?
10 times
10,000. 1,000 just for the F. What's the reason to get 1,000? All right, this is everyone make the mistake. I'm gonna go back to Shiron's work. Okay, Shiron, what's
I wrote
Shiron?
1,002.
You put 1,000 too?
Yeah.
Really? I have no clue why you guys put 1,000. Okay, guys. This one has exponent 1, guys. Exponent 1, exponent 1, exponent 1. So what times it by 1 will be 10? 1,000 times it by 1 is 10? 10 times it by 1 is 10. So why that 1,000 coming in there? Sir, why do you get 1,000? What's made you to think it's 1,000?
Me?
Yeah,
Oh, I did 10 times 10 times 10.
but you need to ask yourself, if you put that 1,000, if you expand it, would you get the same answer? Are you guys following? That's not 1,000? Akshaya
Yeah.
online? All right, so you guys
Yeah.
got this one right, 15, cool. All right, now the next one. So I'm not sure you guys answer it, so we need to move on. So this one pretty easy, because all you need to pick the number that's go for the x. And we know it has an x as an exponent 4, outside you got 2, so 4 times 2 is 8. And this is also easy. So why that h is easy, we know we need to get 14 and 21. So if you have 2 to get 14, this must be 7. Right? All right. Now, what I don't really want to go through it, I want you guys to make mistakes on this handout as your homework. Not quite easy. Some of the questions you will definitely make mistake. So let's go back to one of them here. So that will help you to do some of them. When you got power of power of power, power of power of power, you simply multiply all the exponents. You simply multiply all the exponents. Are you seeing that? Power and power and power, you're going to multiply the exponents. Are you following that part? Yes, sir. Okay, all good? Okay. So we're going to proceed back to, there's a lot of questions here. So I don't really want you guys to spend time on doing it here. You can do that as your homework. So this handout is going to be your homework. So we're going to move back to our handout from last class. Continue off the handout from last class. All right. So where's the handout? July 17, no. It should be July 17 means 17 lesson. So where does my 17 lesson go on the handout? Oh yes, here we go. So we are working on this handout. And then somehow I didn't complete this handout. That's kind of weird. I was doing this handout, isn't it? Exponent row. Didn't I use this handout last class? How have we got it done? How have we run the handout? Didn't I use this last class?
Yeah.
Handout? So where did they write it? Kind of weird. And you see, you check my notes, right?
Yeah.
So where did I write my work? Okay, let's order it, sort pages. Date created, date modified, done. So this is adding and subtracting. This is the homework. Okay, mixed numbers. Kind of weird. Oh yes. Oh yes. All right. Oh yeah, I'm using it here. So which day I was using this? I somehow put it July 24th lesson last week. Well, it makes sense. Last week is July 24th, what I'm talking about. Today's 31st. Okay. I'm confused myself. So we have done so far something here. So we got some questions to work with power of power. And then we talk about exponent rule. So there's a lot of practice there. So what we want to do, we really want to going back to some difficult one to practice. Are you ready? So I'm going to skip some of the slides here. So we did it. We did a lot of practice here. Okay, let's go back to here, 17. Let's do the 17 on the handout. It's on my handout. Can you find the handout? It's on the handout. My handout is going to go for another class. Can you just find that? It's there? Okay. Can you guys apply power of power? Did you find it? Okay. Apply power of power rule to simplify that. That's number, all right. How do you get 9 from? Finding it. Remember we talked about power of power being 2 to the power of 3 times 3 to the power of 4, the power of 5. We just did this. We need to multiply the exponents. Right? See that? Can you fix that? All right. Ooh, what's happening here? All right. The exponent 7 only belong to B. You cannot take that out. It's belong to B. When you put that like this, you know what does that mean? The exponent 7 has belonged to all 3 in A and B, but it's only belonged to B. Did you see where the bracket is?
Yeah.
So that's all right. Done. It's okay to make mistakes. 9, where did you get? Okay. All right, so I think that we need to practice on this. Let me see what you're doing, sir. All right, you guys really need to practice on this. All right, so really need to practice. Okay, let me see what these guys writing fast. All right. So Sharon, what he's right on here. Okay, Sharon, you have learned this one from me, man. I am keep on telling it. All right. All right. This is a problem. This is everyone make this mistake. All right. So I'm going to show you what the problem is. You should not make this mistake. So we're talking about power of power. Think about the exponent. When 3 doesn't have an exponent, it's actually have an exponent 1 hidden, isn't it? We talk about that. When A doesn't have an exponent, it has an exponent 1 hidden, isn't it? We don't write that. Yes, sir. You have a question? Okay. Now, what this exponent need to be done? It's power of power. We multiply those exponent by the 2. We multiply those exponent by 2. We multiply those exponent by 2. Have you seen that? So this is going to be 3 to the power of 2, A to the power of 2, B to the power of 14. Well, you can write 3 to the power of 2, 3 times 3, which is 9, A to the power of 2, B to the power of 14. That's different story. Are you seeing the rule? All good, sir? Is everyone following that? All right. So that's being said, I think we need to going back to some crazy example to see if you guys can actually do this. So actually, you know what? Let me give my question here. So let's call this 18. Okay, can you just do that, please? That's my example. Don't make a mistake this time. This one? So let me zoom in. And you know?
Yeah.
Okay. That's right. Okay, what's the final answer? You can split it. What's the final answer? See, I wrote the final answer like that, right? So you need to write with everything is there. So you split it. Okay, can you write the final answer? Let's see what you write. You did do that, Jack? Okay, so you got that right. You got that right. You got that right. That's what you're doing it. What you're doing. This is right. So this is 2 to the power of 5. Then what you're thinking? Why are you going back to 250? So you got this one right, but you need to write the answer like that, right? And that's it. You can calculate what is that is there. That's a different story. Okay, lady. So you write a to the power of 2 times 5, isn't it? So why do you write again a to the power of 5? 2 times 5 is? Right? So the final answer will be right, 2 to the power of 5. Right? You still get stuck on that, sir? Okay, so we will see what's going on there. Let me see what these guys doing. Are they making the same mistake? Oh, they understand. And it's not right, so I share, so it's right. Yeah, you got the right data this time, so let's see what Shiwan is doing. Okay, yeah. So let's go back to Taiwan. You can imagine it has an exponent 1. Make sense on that? Then all we do is we're going to multiply this exponent with a 5. So 2 to the power of 1 times 5. A to the power of 2 times 5. B to the power of is exponent 1 times 5. So which is going to be 2 to the power of 5. A to the power of 10. B to the power of 5. That makes sense? Yes. Are you just following that? We didn't go back to the complex one yet. That will start sitting on the bottom. A really complex one. So you need to be very comfortable. The exponent rule is going to be continue the next lesson. So you have to be really careful. Is everyone following that rule? All right. So if that's the case, let's going back to there's a one thing I didn't talk about yet. So I'm going to talk about this as negative exponent. So let's going back to the negative exponent on the side note. So 2 to the power of 3, we know, mean 2 times 2 times 2, 3 times, isn't it? We know that. 2 to the power of 3 mean multiply 2, 3 times. What if I say 2 to the power of negative 3? What does that mean? What does 2 to the power of negative 3 mean? Like 2 to the power of 3 mean multiply 2, 3 times, right? So 2 to the power of negative 3 mean? Okay, you don't need to be shy here to answer that question. All right? You need to make mistake to answer it. Okay, so what does 2 to the power of negative 3 mean then? Sorry? Divide. Why did you say divide? Oh, because positive exponent mean multiply and then negative exponent mean divide. You're almost there. Almost there. All right. So let's going back to what is 2 to the power of negative 3 is. So here's what we're going to do. So what we're gonna do is, let's write an equivalent expression. I'm gonna write an expression 2 to the power of 4 divided by 2 to the power of 7. Let's think about this expression. 2 to the power of 4 divided by 2 to the power of 7. We learn exponent rule, isn't it? So when we divide the same bases, what do we need to do for the exponents, Tawan? When we're dividing the same bases, what we need to do for the exponents? When we're dividing the same bases, what we need to do for the exponents? That's right. So can we say this is 4 minus 7? Right? Okay, what is 4 minus 7 is equal to? -3. So did you guys agree with that? 2 to the power of -3, I can express something similar to this, isn't it? I can do this to express 2 to the power of 3, isn't it? Okay, now let's going back to doing some math. Let's write this expanded form. 2 times 2 times 2, how many times? 4 times. On the denominator, I got 2 times 2 times how many times? 4, 5, 6, 7 times. Everyone seen the picture? Right? All right, now we have learned how to simplify the fraction easiest way. If you have a factor in the numerator and denominator, we can divide, isn't it? So 2 divided by 2 is 1. 2 divided by 2 is 1. 2 divided by 2 is 2 divided by 2 is 1. On the numerator, we got 1. On the denominator, what do you have? 2 times 2 times 2, isn't it? How many 2's we have? 3 2's, isn't it? 1 over 2 to the power of 3, isn't it? So let's see what the connection is. When you have a negative exponent, we can switch the negative exponent to positive exponent by rewriting into 1 over same base and then change the exponent to positive. So this is going to be 1 over 8. So what does that mean? Let's go back to another example. 2 to the power of, actually 4 to the power of -2. So when you have a 4 to the power of -2, the rule is 1 over 4 to the power of 2. Don't change the base, only change the exponent to positive. Well, you know that is going to be 16 4 times 4, isn't it? So most common mistake people do. Most common mistake. Some of you are going to write like that, which is not right. The rule is when you have a negative exponent, only change the exponent to positive by flipping it, not the base. So how this will work? This is going to be -3 to the power of 3, isn't it? Are you seeing that? Evan? And Vaishali on the back? Well, you can use your calculator to multiply 3, -3 times -3, +9, +9 times -3, -27. So far, so good. Yes? All right, so we're going to moving back to negative exponent. A non-zero number raised to a negative exponent is equal to is reciprocal. Reciprocal. Raised to the opposite positive half. So reciprocal means flip it. So some example here. X to the power of -3 is 1 over. And then here, when we simplify, what's going to happen? You know this is going to be x to the power of 3 minus 5, x to the power of -2. We can rewrite as x to the power of +2. Have you seen that? All right. So can you guys do A and B for me here? Do A and B using the rule that you have learned, simplify A and B. done? Right. Want to try to complete some of them here. I'm gonna come back to see how to do that. Oh, okay. All right, there are some mistakes in some of the questions. We'll talk about that. Right answer, but you don't write the step like that. That's not right. It's not 6x cubed minus 3x to the power of 7. So this is divided. So what happened to the x? Can you tell me? Where's the x goes? How about disappear? You tell me how about disappear? Okay, lady. The 6 is 6. You cannot put that down. So this is 6 times x to the power of 4. You cannot put the 6 down. Only this one is going to be. Make sense? All right, so how's that one? Okay, so you got that, what you minus 4, but you need to leave the answer in positive exponent. Remember, we're talking about how to switch back to positive exponent. Yes. So 1 over. Keep the base, and you change the exponent to positive, right? All right. Let's see what these guys have done on the line. Yes, so let's point back to Axios work. So much is the one. All right. Yeah, you're on the right track, Akshia. And then Sharon, what you doing, man? I'm confused myself. What you're doing?
Me?
So first one, you say x to the power of 1 over 4.
Yeah.
No. Where is that rule coming from? This is x to the power of -4. So 5 minus 9. X to the power of -4. That is 1 over x to the power of 4, sir. What you're writing?
No.
You're writing x to the power of 1 over 4?
Yeah, no.
All right.
That was
All right.
no, I do not remember. I think I was tweaking a
All
bit.
right. Now, can we simplify the numbers? 6 divided by 3 is 2, isn't it?
Yeah.
Now, x to the power of 3 minus 7, right? So 2x to the power of -4. We learned how to write a -4. And then, by the way, ladies, so you put 6. I'm not sure where the 6 coming from anyhow. So this one can be written as positive exponent form by writing it, bringing back to down, isn't it?
Yeah.
You got 6. That's not right. 6 divided by 3 is 2. All right. Is everyone with me on that?
Yep.
Come on, are you following that? All right, I'm not going to this. I'm going to go back to the difficult ones. There's a lot of difficult ones. All right, so which one we're going to work with? These are easy. 9. You guys going to do number 9. Show me all the steps. You done with the 9? You're not applying the power of power rule. So here's what you need to be careful. when you have u b, this one has an exponent 1, 2 squared v to the power of, are you following that? Which you're not doing it. You forget to distribute in this exponent to every single guy that's inside the bracket. All right, makes sense? Okay, fix it. That's not quite easy. I'm expecting you will make a lot of mistakes, but you know the bed mass, and you do the numerator first, and then you do the denominator, and then apply that exponent rule. You got 2 to the power of 1 u squared. And then how do you get 6 here? U squared, how do you get 6? Okay, I don't want to say there's a lot of mistake here. So what you should not do is you should not separate work. You need to write the work the way I'm doing it. You're not separating the exponent to your work. You need to bring in a practice to organize your work. So in grade 9 math, there's a marks for communication, as you said. Some teachers like to take marks off for the communication. right? So you need to show clear work. So apply the rule in each step. Using a pen match, you apply the rule. I will show you how to write it. You get stuck when you get a scary one. Okay, that's a scary one. A lot of mistake from everyone. All right, let's see what these guys do. Online youths. All right. So my online youths, what these kids are doing, 4, 5. All right, so they still figuring out. So let's see on who's doing it. So that is your final answer, sir. 16.
Yeah.
All right, sir. I think that I have mentioned in the Stopakarna, right? I'm not sure. Did you go to temple? Of course. Did you go to temple, sir? Shiran?
No. Well, I go, but I haven't gone in a while.
For a long time. But you know the religion, right? So in front of the god Ganapati, the elephant face guy, you will do Topakarnam. That's a good exercise to not to forget certain steps. Right, man? Let's work out. All right. Back in the days in my school, when you're not wearing shoes to the school, we have monitors, prefects. So it's kind of dictatorship, but we still like it. So they would come in and then check who's in the class and wear the shoe. So they will call them outside. After school, you need to stay, and then you need to write. There's no copy and paste. You need to write 1,000 times. I will wear a shoe tomorrow. 1,000 times. And then me and really still upset with my principal when he was a student in my school. He came late. And then unluckily, that's the date he was arrived late. Just 2 minutes. The principal asked me to stay after school for 1 hour, right? So detention worked. And then you guys are making the same mistake again. Let me show you what the same mistake. Okay, you need to organize your work in grade 9. So first numbers, -2 times 8. Well, that is 16. You see Ju has an exponent 1. This one has 2. So when we multiply the same bases, we need to add the exponent, isn't it? Isn't
Yeah.
the rule say? Yes?
Mhm.
Then we got a V. So V cubed plus 2. We need to add the exponent. All right. Now going downstairs, power of power. We have been working in the power of power. This 4 has an exponent 1. U has an exponent 1. 4 to the power of 1 times 2. U to the power of 1 times 2. V to the power of 4. How come you missed the 2, man, on the 4? Sharon,
Yeah.
how did you miss this? You have been making the same mistake. Yeah, everyone making the same mistake again. 16 u cubed v to the power of 5 divided by 16 u squared v to the power of 4. Are you seeing that right now?
Yeah.
Are you visualizing it? What's happening? All right, 16 can be divisible by 16. That's fraction. Now we're going to apply the exponent rule for the u. 3 minus 2 v to the power of 5 minus the u to the power of 1 v to the power of 1. This is uv. You got the same answer, uv?
What negative?
Well, why do you get negative uv? Where's the negative? Oh yes, there's a negative should be there. Yes, you're right. The minus 16 minus. There's a minus on the top. Okay, cool. All right. All right. Did you guys copy it? We're gonna moving back to some difficult one. Oh, you guys are still copying, okay. And are you following that? What's happening? I don't know what I want to give the next, but oh yes, let's do one more question. So can you guys do number 10 this time, please? Number 10. Oops, let me move that. Okay, you can see my work. Number 10, don't make mistake in number 10. And okay, all right. So, yeah, that's right. All good. Yeah. You still need help with that. Okay. You which one? Oh, 10. Okay, so you got the first part right. You got this part right, this part right, and then y minus 1 all coming in. So you see that this is multiplied. So technically, what's happening when you like 2m and is that. So this one 2 times n times n times 3 times n squared times n, isn't it? So you multiply 2 and 3. Then this m has an exponent 1. So when you multiply the m, you're going to use the exponent 4. So let's do this 3. And then n has an exponent 1. 1 use the exponent of that, isn't it? So how do you make it work? So this will be modified. See that? This will go to the bottom, right? And then apply the exponent rule again. Yes. All right. So let's point back to Shizen. So how does this work? So this one has exponent 1, isn't it? And then the n also has an exponent 1. So we distribute the 2 to this exponent. So 3 to the power of 1 times 2 is 3 squared. N to the power of 2 times 2 is n to the power of 4. N to the power of 1 times 2 is n squared. So this I get divided by this one, it's multiplying all. So we multiply 2 and 3. What do we get? 6. You got m, you got m squared, isn't it? So then this one has an exponent 1. And m to the power of 1 plus 2, isn't it? M to the power of 1 plus 2. So this m has exponent 1. This m has exponent 2. So we know when we multiply in the same bases, we have to add the exponents, isn't it? Following that, and this one have n to the power of 1, this n to the power of 1, isn't it? So n to the power of 1 plus 1. Make sense? And then you work from there. So this is 3 squared 9. 4. Right? Now we can simplify the fraction. And then we divide the same basis. Right? Follow that? Go from there. Let's see what you're doing. Are you doing the question? Just for 10? You do something else? Okay. And then what did you do? What did you get? Did you get some 0.5? What's going on here? Say what? Making the same mistake. Poor Carmen is the only choice. Okay, I think I need to make you guys to make poor Carmen so you won't forget. All right, you make the same mistake again. Same mistake Sean made. You forgot to multiply some of the bases. Let's point back to see what these guys doing. Actually, are you following the lesson?
Yeah.
Okay, so let's going back here, what she tried to do on that. Okay, square, okay, so far so good. Cool, okay, she's on the right track. Let's see what she wants to do. Did you copy the question wrong, sir? Why did you put 3n squared? Where is that squared coming from? Anyhow, so this is going to be, guys, exponent 1, 3 to the power of 1 times 2 is 2, m to the power of 2 times 2 is 4, n to the power of 1 times 2 is 2, isn't it? Are you just following that?
Yep.
2 times 3 is 6. M to the power of 1, m to the power of 2. We're multiplying on the bottom. So m to the power of 1 plus 2. And then n to the power of 1, n to the power of 1, n to the power of 1 plus 1. Are you just following that?
Yep.
And your name again? Akshara, yes. Akshara, are you following that step so far? 3 squared is how much? 9. M to the power of 4, n squared. Over 6, m to the power of 3, n to the power of 2, isn't it? Now we know how to simplify fraction. What number, Akshara, can divide 9 and 6? What number can divide both 9 and 6?
3.
So that is 9 divided by 3 is 3, 6 divided by 3 is 2. Now exponent rule, m to the power of 4 minus 3, n to the power of 2 minus 2. So which will result in 3 over 2, m, and then n 2 minus 2 is 0, n to the power of 0 is 1. And that's your final answer. Make sense? Vaishali, are you following that? Are you following that, sir? I need a lot of practice. That's what the homework questions are for. So how many of you heard about EQAO? No one heard about it? You didn't do EQAO in grade 6? Pandemic?
I went to a different school. They didn't have it.
Private school? Where did you go?
One second.
Why did you go to Town Center Montessori?
That's my dad made me.
Okay, so you went to Town Center Montessori. Town Center Montessori doesn't want to give that EQAO. Okay. How about other people? How many of you know EQAO? You guys don't know? Okay. You
I
know?
do.
What do you know
Yeah.
about EQAO?
An exam that you take in grade
Exam.
6,
Yeah, okay. Exam you take in which grade?
grade 6, and I think 1 and 3.
Okay, so you're saying in grade 6, okay. So EQAO, it's basically a standardized exam or test. It's run by the province in different grades. They do first in grade 3, math and English, grade 6 math and English, and grade 9 for math only. So in grade 9 math only, that marks you got from EQAO, so 10% of the marks will go towards your final exam, final marks. So your 10% of the final mark will be based on the EQAO. So EQAO, it's all multiple choice questions. So there are around 60 questions you'll be answering based on the concepts you have learned. The difficulty level will increase over the question based on how well you're doing it. But it's also tell how well your school is doing. They're just looking at the school scores. So let's going back to an EQAO sample question on this. So let's going back to an EQAO sample question on this. So let's see. All right, so I'm going back to where we are right now. We're on the algebra unit. Yes. And then multiplying. So we have power of power and product and quotient. That's what we're working on. Power of power. Okay, EQAO problem. All right. So we're gonna take a turn that you guys are gonna be answering. So let's do some practice. The table below contains 5 expressions. How many of these expressions are the equivalent to equivalent to p to the power of 2 whole thing cube. So you can have a minute to look at it. There are 5 expressions given. The question is asking how many of them are equivalent to this expression p squared to the power of 3. All right. So don't answer it. I'm going to go around to asking questions. Aaron, how many of them are equivalent to that? You say 3. 3. 3. You say 3? 3. Okay. So how about Akshaya online?
3. Yeah.
3. Sharon?
Yeah, same 3.
Okay, 3 is the right answer. So I'm not going to discuss what are the right answers are. All right, so answer C, which is 3. All right. So that's the one question here. Now, where is another question part of? Let's going back here. Some of them are not quite easy. Hold on. All right. All right. So I want you guys to looking at question number 4. Question number 4. Oops. So everyone looking at a question number 4. Oh no, question number 4 is not straightforward. That is a little tricky. I don't want to do that. Okay, let's go back to easy one. Let's go back to easy one. Do you have an easy one? You're not there yet. Okay, I will keep that. I will keep that questions later. So we're gonna moving back to handout, guys. So we're gonna going back to right now further in algebra, which is called communicate with algebra. So what we're gonna going back to the next step is you have all learned about a little bit about algebra. You have learned about writing algebraic expressions. Did you guys learn writing algebraic expressions in grade 8?
Yep.
All right. What is algebraic expressions? To write algebraic expression, what do we need? Akshara. Sorry? To write algebraic expressions, what do you need? You can be a little louder. You need BEDMAS. Well, you need to know BEDMAS to simplify it. To write algebraic expression, what do you need? By shout. To write algebraic expressions, what do you need? Variables. That's right. Have you ever heard about it? Let's x be the age of John, and then let's y be age of Taman, right? X plus y is 20. All right. So we're gonna see how to write algebraic expression. So let's go back to a simple example. In the diagram, what is the area of the triangle? This is a brain teaser. You can do that for next class, but we're gonna moving back to the question. A hockey team get 2 points for a win and 1 point for a tie and 0 point for the loss. Right? An equation determining the amount of points a team has. So let's going back to see how to respond to this question. So write an equation for determining the amount of points a team has. So to write an equation to amount of points, we have to introduce variables, right? Because we don't know how many games they win. Do we know how many games they win? No. Do we know how many games they in tie? No. But we know how many points they will earn in each scenario, isn't it? So when we want to introduce a variable to represent an unknown quantity, we have to use a specific word. So let's go back to Akshara again. What is a word that we have to use to introduce a variable? To introduce a variable, we have to use a specific word. What word should I use to introduce a variable in math? Aman?
Like a let statement.
Yes, a let statement. So we're gonna use let statement. Let P be the total point. P be the total points. It's important to use a variable name that's meaningful. And let W be the number of wins. number of wins. Let L be the number of losses. And let T be the number of ties, isn't it? Are you guys following that? Make sense? You see that names I'm using it? P for the total point, W for the number of wins, and then LB for the number of losses, isn't it? So now we're gonna write the equation. So let's see how we write the equation. P, the total points. You got 2 points for each win, 2 times W. And 1 point for a tie, you're gonna get 1 T, 1 time T is T. And no point for the loss. So the total point you will be earning is 2 times the number of winning points plus T times 1, which is T. You copy now, sir? All right. Can you guys use that equation to find the answer for B, please? And then I will ask verbally. Use this equation to find the answer for the next question in B. Yeah. Is it good enough to see it? So first statement, let P be the total points. The next statement say let W be the number of wins, and let L be the number of loss, and let T be the number of ties. I'm not sure. I need to find a way to put the projector so it won't be blurry. Mounted on my wall. Yeah, man, do your parents want to see your sister? She didn't come back on weekend. Busy on her
She
thesis.
did, but I don't know. I think she needs something, so they like went to go.
Okay. Courier service.
Basically, yeah.
All right, can we move on? All right, why did you guys get the total points? Janny. No, how did you call your name again? Jan. Yes, Janny. What did you get for the total points?
160.
160. Is everyone got 160?
160.
116. Is everyone got 116? All right, so how do we calculate the total points? You got 2 points for each game you won, and then you got 1 point for each tie. So 108 plus 8, 116, isn't it? Are you seeing that? Pretty straightforward. All right. Now, this is important because let's imagine based on, this is basically the formula I developed, isn't it? Sometime I need to play around with different teams and then see what are the chances we will proceed to that next level. So if you don't have a mathematical model, I can't really predict what will happen, isn't it? So you really need to know the mathematical model. So to generate mathematical model, you need data, isn't it? If you don't know the data, you can't really see who will win, who's not win. So how do you collect data? What do we have to do? To collect data on a game, what do we have to do? To collect data about a game, what do we have to do? What do we have to do to collect the data about a game? Come on, you need to follow the Canadian women's soccer team. So what do you have to do? Send a drone, steal information, and model it so we can win the game, isn't it? All right, that's not how it's worked. You have to looking at the past statistics, and based on that, you predict it. And then when you know how to make a prediction, what you have to do. So when you know how to make the prediction about the game, what you have to do. When you know who will win based on the model, what you have to do. You don't know what you have to do? How about my online guys? If you predict
Put
who's
it.
gonna win today's, sorry?
What? Sorry, no, continue.
So if you make the prediction based on the past data and then you come up with a mathematical model and you predict today that let's see that the Raptors is playing against another team and then your mathematical model predict the Raptors gonna win. Then if you know the prediction, what you have to do?
Go bet on it.
What?
Put it into a. I don't know. I'm not sure actually.
You have to go to the gas station and buy a lottery ticket called Proline and then scratch it. Today Raptors will win, and then you can get money. But you don't have the right ID. So maybe ask your parents. I learned how to mathematically model a game, and I know Raptors are going to win, and people are going to laugh at if Raptors are going to win. I was telling that somebody, the only Canadian sports I know. Did they mention to you Raptors? What were they mentioning about Raptors? Anyhow, I'm mentioning about Raptors. Somebody started laughing. You're talking about Raptors? Yeah. Well, I'm talking about a 2019 team. Oh, no one have a hope on Raptors anymore. Anyhow, okay, let's move on. Do you guys know there's a gambling called Proline? You can go back and check about soccer games going on, cricket games going on, and then hockey game going on. You can bet on who will win. But the only problem with that is the price for the betting is $10,000. If 10,000 people predicted correctly buying a ticket, you only get $1. They don't pay the $10,000 to you. So if multiple people actually predicted, then the price will be distributed among multiple people. All right. So let's going back to part 2. So we're going back to more algebra now. So when it's come to algebra, we're going to be use the first thing called term. A term is an expression formed by the product of variable, product of number, and product of variable. We're gonna write product of variable and or a number. The number in a term, we're not going to call this number. The number in the term is going to be called as coefficient. You probably see the word in grade 9. If you didn't see the word, you're going to see the word coefficient today. So it's an expression formed by a product of variable and a coefficient. So the number in front of the variable is called, I already mentioned, is coefficient. So if you look at here, the coefficient in this example, the number in front of the variable, it's just 4. The variable is x. We don't worry about the exponent. The exponent will play some important role. We will talk about that later. But the variable is just x, right? So here's the practice. You guys can tell me. So my term is right now minus 1/2 x squared y. That is my term. Minus 1/2 x squared y. So let's going back to Taman. What is the coefficient of that term? Minus 1/2 x squared y. What is the coefficient? Sorry? What is the coefficient of the term? Yeah. What is the coefficient of the term minus 1/2 x squared y? Negative 1/2. Most mistake. Negative 1/2. Are you guys following that? Right now, we're going to go back to variable. What is the variable? So let's go back to Akshay online.
X and Y.
That's right. There are 2 variables involved. X and Y are the variable here. We don't tell x squared as a variable. The exponent plays some role. We will talk about that in a moment. All right. Now, we're going to going back to some little calculation here. Identify the coefficient and the variable for each term. James earns $7 per hour at his part-time job. If he works for X hours, his earnings in dollars are 7x. So, going back to Aaron, what is the expression for that part A? What is the expression for part A? The expression for question A. It clearly says what the expression is.
7x.
All right. Now let's go back to command. What's the coefficient? Akshara, what's the variable? Thank you. I'm not worrying about the comments here. So Akshara, I'm going to start from you for the next one. B. The depth in meters of falling stone in the water well after t second is minus 4.9 t squared. What is the expression? Which is the expression? Negative 4.9. Why you're eating the negative 4.9? Negative, right? All right. And Vaishali, what's the coefficient? Negative 4.9. Akshaya online, what is the variable?
T.
Thank you. All right. Sharon, sir, what is the expression for the third one?
1/2 times B times H, or 1/2 BH.
All right. What is the coefficient?
1/2.
1/2. What are the variables, Tavan? C. Sorry? B and H. B comma H. All right. The area of the square with the side K is K squared. Expression, Akshara. K squared. Tavan, what is the coefficient? Well, K is a variable. So K is the variable. What? Yes. 2 is the exponent. We don't talk about 2 now. So there's nothing in front of it, isn't it? So most common mistake, people say 0. And when nothing in front of it, it's just 1. Makes sense? We don't really write 1k squared in math. It's an ugly format. All right. Are you ready now? All right. Now, something I didn't talk about it yet. Degree of a polynomial. Oh yes, likely term is coming out. Okay, we will talk about it in a moment. All right. Now we're going back to polynomial. A polynomial is an algebraic expression consisting of one or more terms connected by addition or subtraction. So a polynomial expression is consisting of one or more terms. You can have one term or more than one term, but connected by addition or subtraction. So they give an example of a polynomial. You can see 3x squared plus 2x. You can see there's an addition involved. Now, a polynomial can be classified further by the number of terms. So a monomial, is a polynomial with one term. One term, we call binomial, bicycle. 2 terms. Trinomial, tricycle. So now, mono, bi, tri. So what is the next Latin word for 4? These are Latin words. Mono, bi, tri.
Oh, I know.
Yes.
Quadnomial.
Yes, that's right. Conomial. Conomial. Nobody's going to be called conomial. We're not going to work with conomial until you're going back to grade 11. So we will be working with monomial, binomial, trinomial, unless the math curriculum is going to be changed. By the way, who is our Minister of Education?
Doug Ford?
So can you say that again, sir?
Wait, is it? No, wait, never mind.
I heard that.
Doug Ford?
Minister of Education is Doug Ford.
Yeah.
Okay. All right. He's the Premier of Ontario. So who is the Minister of Education? Do you know him? I don't think so. You guys know him. Okay, so I'm gonna say, is that Stephen Lecce?
No.
All right, one person say no. Stephen Lecce? Stephen Lecce? No. Eric Smith? No. Vijay Tony Hassler? Raymond Cho? Ted Smith? I think I gave the name. So you guys didn't say yes.
The second,
Which one?
the Eric Smith.
Eric Smith? No, he's a new. So we have education minister was former education minister was Lecce. Right now we have Todd Smith. So he's the new minister of education. He used to be a minister of education for. He used to be a minister for energy sector. Okay, let's move on. So let's ask from Taban. Taban, how many terms are here? Number of terms on the first one. How many terms in the polynomial? That's right, 2. So if you have 1 plus sign, 2. So we're gonna count the number of plus and minus sign. So therefore it's binomial. Axial line,
1.
1 term, monomial. RNE, 3, trinomial. And Akshara here, last one. Sorry, how many terms are there? Huh? The last one, you got 2 terms, 3 terms, 1 term. Let me highlight the terms, right? So 1 term, 2 terms, 3 term, 4 term. So here's what you can do. Look at the number of minus and plus sign, and then add 1 to it. So there are 3 minus and plus sign together. Add 1. Conomial, isn't it? All right. Now we're going back to another terminology. It's called the degree of a term. Degree. A degree of the term is a sum of the exponents of the variable. Sum of the exponents of the variable. So if you go back to a simple example, 5x squared y cubed. How to find the sum of the exponents? So x has 2 plus 3. So that is 5. The order of the degree of the term is 5, isn't it? Have you seen that? How do we get that? All right, so we're gonna next practice. So Taman, what is the sum of the terms in the first expression? Sum of exponents. So if you add all the exponents, how much? Are you looking at the right question? We are in here. So if you add all the exponents, what did you get? Huh? You got 3. Where did you get the 3 from? How do you get 3? I have x squared. Where's the 3 coming from? Right? So the degree of the term is 2. Akshara. Second one. 7. Where is the 7 coming from? You need to add all the exponents. 4. Vaishali. So how did you forget? U has 1, V has 1, 1 plus 1 is? And Jenny. Where did you get 4 points? Huh?
3.
Yes, B has 1, 2 plus 1 is 3, isn't it? Irony. 0, we don't have variable. You only need to count the 1 on the exponent on the variable, not in the number. So the degree of the term is 0. Makes sense? Are you following that picture? So a variable that appeared to have no exponent actually have an exponent of 1. A constant has a degree of 0. So -5 is a constant. All right, now let's going back to the net. Are you guys following that so far? Pretty straightforward stuff. Now we're going to define a degree of a polynomial. We define degree of the term. The degree of the polynomial is equal to the degree of the highest term. Degree of that, so equal to the degree of the highest term in a polynomial. So what does that mean? We're going to looking at this. Let's put the degree of the first term. The degree of the first term is 2 plus 4 is 6, isn't it? The degree of the second term is 2 plus 2, 4, isn't it? The degree of the last term is 5. So what is the highest degree? The highest degree term is x squared y to the power of 4 with a 3. The degree of the highest degree term is 6. Degree of the polynomial is 6. So are you following that? How to get that? So this one say highest degree term. So we need to write the whole term. And the degree of the highest term is, which is exponent, sum of the exponent. The degree of the polynomial is the highest degree of any term. All right, so let's start with Akshara. Term with the highest degree. Which term has the highest degree here? 3. 3 doesn't have a variable. Look at that picture, lady. So the degree, so there are 2 terms, isn't it? Okay. When you look at the 2 terms, this is the first term, this is the second term. So let's underline the first term and second term. We just learned the degree for just the number is 0. So what is the degree of x? Let's go back here. Let's go back to read this. A variable that appears to have no exponent actually have an exponent of. So what is the degree of that term? 1. So the term with the highest degree is x. That's my term with the highest degree. The degree of that is 1. Degree of the polynomial is. Are you following that picture? Okay, come on. Can you tell me the next one, sir? What is the term with the highest degree? That's right, 5x squared. You're going to tell me the rest. Degree of the highest term, sir? The degree is the number. Huh? The degree is 2, man. This is the term. The degree of the term is the exponent to that. Sum of the exponent of the variable, right? Degree of the polynomial is 2. Okay, go back to Akshya Online. Akshya Online. What is the degree with the highest term? Term with the highest degree, Akshya.
3y to the power of 3.
3y to the power of 3, correct. And then can you tell me the next one? Degree of the term with the highest degree is?
3.
And then degree of the polynomial is, okay. So let's going back to Tavan. Okay, Tavan, next one. The term with the highest degree, sir. Y to the power of 4. And then the degree of term with the highest degree is 6. The degree of the polynomial is 6 because 2 plus 4 is 6. Make sense?
We did it, class. We did it. Yay! Yay!
All right. Who's that get excited? Is it Sharon or it's coming from Akshia?
It's not me.
Or Akshia? Hello?
Yeah.
Akshia,
Yeah.
what's happening? Brother? Sister?
Yeah.
Okay. All right, so we're gonna move forward. Right, so we need to go back to the collecting likely term. That's something I really want to dive in, and adding and subtracting polynomial. Okay, we have enough time, so let's go back here. All right, guys, so we're gonna go back to a simple practice here. Mr. Jameson works part-time as a golf instructor. He earns $125 for the season, plus $20 for each children lessons and $30 for each adult lessons he gives. Write an expression that describes Mr. Jameson's total earning for the season. Identify the variable and what they stand for. So can you just do that question? We did a similar question in the beginning, introducing the right variable. All right, so let's see what she's doing here. So who's gonna write the let statement? Let's see, let, did we do a similar type of question? You're introducing variable, right? Then you have to use the statement let. You don't say let exists until when that what? Yes, you need to write that let x be the number of children. You have to write C be the number of children, not C be the child's children. And then it's okay to use an uppercase variable, but the uppercase variable is used in the specific places, so we're going to keep the variables lowercase. Okay. Okay, you're on the right track. That's what you write, sir. Who's going to write let the variable names, right? So when we have a word problem, we have to introduce variable, right? So to introduce variable, we're going to use the keyword let, and you are missing that. All right. So what we have to do is, let's see what these my online folks has been doing. Okay. you're not done yet, so I need to move on. So let me quickly do this question. So we're gonna say let C be the number of
Children's lessons.
lessons. And let, what else we have? Adult. A be the number of adult lessons. And let T be the total total earning. So I don't have space, I'm gonna squeeze it here. So the total earning T is equal to when he charged $125 he's earning, plus $20 for each children lessons, and plus $30 for each C. And then $30 for each child lessons. Make sense? All right, are you following that? All right, I'm gonna skip that review of the term. So we need to moving back to something called collecting likely term. All right, a likely term. So what is likely term?
Teacher, can you go back up?
Yeah.
Okay, yeah, thank you.
All right. So what is the likely term? That's what something we need to talk about. A likely term, I'm going to define a likely term. The definition is from there. You guys can write it. A term with same variable with same exponent. So if I have a term that has the same variable with the same exponent, we call it likely term. So let's do some example here. We don't care about the coefficient, 2x squared y, and then 2yx squared. These two terms are likely. Why they are likely? Let's go back here. I don't care about the number in front of it. I will care about the variable. Do I have an x both places? Yes, I do. What the exponent I got 2? What the exponent I here? 2, isn't it? Do I have a variable y in both places? Yes, I do. But the exponent for y I got 1. So therefore, we call this likely term. So let's go back to another example. 3ax squared y minus 1/3 a y squared x. So let's go back to Taman. Taman, do you think those two are likely term? So, okay. Are they likely term? So let's double check. Sir. Do we have a both places? Right? Exponent 1. Do you have x both places? Yes, I do. But the exponent for x here is 1. The exponent for x here is? So they cannot be likely term. Are you following that? So they're not likely term. So why do I need to take the line? Why do we need to consider likely term? Likely term is like, we can add apples with apples, not apple with mangoes. You can add two likely terms together using a regular addition, but you cannot add two non-likely terms, right? So we're gonna going back to here. Let's do it now. What is the degree of the term? So let's go back to Akshara online. What is the degree of this term? I'm here. What is the degree of the term Akshara? Simply add the exponents on the variables. If you add the exponents on the variable, what would you get? How come? Don't you got y has exponent 1, c has exponent 1. If you add all the variables, 2 plus 1 plus 1, what would you get? That makes sense? Right? Does it make sense? Akshara? Okay. Okay, now going back to Tavan. So let's look at number 2, sir. What is the degree of this polynomial? So what you have to do, sir, let's look at this term, find this degree. So sum of the exponents, isn't it? 2 plus 3, 5 plus 1, 6. Second term, 1 plus 4, 5 plus 2, 7, isn't it? The next one, 1 plus 1, 2 plus 2, 4, isn't it? Make sense? So what is the degree of the term? 7. All right. So what we're going to be working on is, you guys already got the power of power homework handout. So I'm trying to see I can give the algebraic expression handout. All right. So you guys can get algebraic expressions handout. Algebraic expressions. Okay. Algebraic expressions, writing algebraic expression. We have done some charts today, so you should be able to do that. Yes, this is an algebraic expression. The algebraic expression handout is there online, posted from the last week homework. Okay, do that algebraic expressions. Now we will talk about adding and subtracting, collecting likely term, because that's something I'm not clear show you what to do yet. So that's something we're going to be focused on. That's something we're going to be talking about next class, adding and subtracting. So that's going back to my online folks. Moving back to my online folks, I'm going to show you what your homework for next class is. So I posted as the July 24th lesson. No, where did I post it? Last class. No, I post the files. Where's the files goes? Let's see, somewhere.
Is it July 31st?
Sorry?
Was it July 31st? Homework?
Yes, sir. Yes, yes, yes. So what you guys gonna do? Multiplying and dividing power with the same base, you guys gonna do. And then adding and subtracting polynomial, we didn't talk about that. We didn't talk about that. So I need to give the handout for this. So this is going to be algebraic expressions. So writing algebraic expressions. So I'm gonna give this algebraic expression. So here's an algebraic expression handout. So I'm gonna copy this link, and then you can access as a link there. So if I going back to edit this, I have to edit that. Okay. So I'm gonna add a link. So add attachment into the link. All right. So you can access the homework, the power of power, and then also the algebraic expression is what the homework is going to be. All right. So
Okay.
I will see you guys again next week. And then how's the homework?
I mean,
Some of them is done.
who's on?
Sorry,
Just didn't finish it.
already. Already done.
I didn't finish it.
And the rest done. Okay, I'm gonna give it back. So Jane, that, and that's yours, sir. That is yours. That is yours. And it's almost that one page is done.
Yeah.
So we get the challenge. March. This page is done. So I really enjoy your vacation, I believe. All right. Stop the rest. I will see you guys next class. Okay.
All right.
I